Hey guys, it is time for section 8.2. So we've added and subtracted polynomials. Today we're going to look at multiplying and then factoring. Factoring is kind of like dividing, because you're going to divide out terms within the polynomial that can be divided out of every term, and that's known as factoring. So it's called lots of different things. We'll take a look at those. It's a little tricky, so we're going to spend lots of time on factoring over the next week or so. Make sure you document questions, anything that you're stuck on, so that we can talk about it in class. All right, let's take a look. It is the 14th. Happy Valentine's Day. This gal is setting apart a side of a rectangular plot of land for a garden and seed the rest of the plot for the grass. So this whole thing is her garden, but she's going to cut out 10 feet of it and then put grass over here on this side. So we want to take a look at, let's see, grass seed costs 3 cents per square foot. Write an expression for the total cost of the seed. Suppose you buy $50 worth of seed. How wide can this section of grass be? Explain your reasoning. Okay, so since we have a rectangular plot, remember from before that area is equal to length times width. So our cost is going to be the square foot of this total area here, less this piece of the garden. So I know that my cost, the price, times the area is the expression. So then I want to think about, what is the price? Well, it's 0.03 per the area, which is 3 times W. So then we go 0.03, start substituting the pieces we know. We can call the length, what do we want to call the length? 45? And it doesn't matter which length we're calling, so as long as you're consistent in what you're doing, you're fine. Then we want to multiply that by the width. The whole width is x, but we're taking away 10 feet. So we have x minus 10 is going to give me the cost of that thing, the expression that represents the cost. So we need to just use our algebra skills and bust out a calculator. Okay, so what we're going to do is with our calculators, we're going to put, since we're multiplying, we're just going to multiply straight across. So I'm going to start with these two terms first, and 0.03 times 45 is going to give me 1.35. And then I still need to multiply it by this polynomial term, x minus 10. So since it's within parentheses, we're going to distribute, so we get 1.35x minus, what is that, 13.5? That's the expression that represents the cost. Well, it tells us, hey, I got $50 worth of seed that I can buy, and I want to know how wide I can make this garden with my $50. So I know my $50 needs to equal whatever that stuff is. Once I solve for x, I'll know how wide my garden is. So I do some math. I add 1350 to put this side. I get 6350 is equal to 1.35x. We divide both sides by 1.35 and we find out that x is approximately 47 feet. So that is how wide of a garden we can plant our seed on. So we're going to do stuff like that today. It's multiplying and working through that. So basically what we've already been practicing with is that, hey, you can use your distributive property to multiply monomials, remember, single terms, and polynomials. Multi-term expressions. So multiplying a monomial and a polynomial. Let's start with some examples. So we have 2x times the quantity x plus 8. We've been doing this all semester already since the beginning of the year. We know that 2 times 1 is 2. X times x. Let's make a note. Add, expose when multiplying common bases. Okay, so that's just a reminder of the stuff we have to know. We need to know that rule that we learned last chapter. So since I have x times x, that's x to the 1 times x to the 1, which is x squared. 2x times 8. 2 times 8 is 16. x times essentially nothing, but x comes along for the ride because this whole term is being multiplied and the variable comes with it. We make sure it's in standard form, which means that we start with the highest exponent and work our way down, so we're good there. Sometimes you'll see it set up like this. It doesn't matter. So even if it's backwards like this, it's still distributing. This means n times 5 to the n plus 7 times 5 to the n. So it's the same process that we've been doing mentally. That's what happens if you set it up individually. 5 times 1 is 5. N times n is n squared. 7 times 5 is 35. And n needs to come with it. We are in standard form because we're decreasing left to right with our exponent. Let's try another one. Let's do this one. 6 times 7 is 42. H, I'm not multiplying by any other h's, so I still have h squared. 6 times 1 is 6. H squared times h. I add the exponent, I get h to the third. So we need to watch, though, that, hey, this is not in standard form, so I need to rewrite this in descending degree order. Let's make sure that's 3. Okay? Let's try another. So now my monomial is negative. That's all right. You guys know how to multiply negatives. Same process. Watch your signs. We all know what happens when we make sign errors. Negative 1 times 2 is a negative 2. T squared times t to the fourth is t to the 6th. Negative 1 times a positive 4 is a negative 4. T squared times t is t to the third. And negative 1 times a negative 8 is a positive 8 t squared. Don't forget to bring along your variable when you multiply your final constant term. And we're in descending order, so we are in standard form. So we're good there. All right, last one. Let's try another one. We're going to distribute that across. 5 times a negative 1 is a negative 5 d to the fourth. 5 times a positive 2 is a positive 10 d to the third. And 5 times a negative 3 is negative 15 d squared when I add my exponents because I'm multiplying common bases. All right, you should pause the video, try the next 3, then come back and check your work. Alrighty, those are the answers that you should have gotten. Pause your video, make sure you got those right. If you did not, make sure you go back, rework the problem, make a big fat star, circle it so that we can talk about it in the morning. Try and figure out where your mistake is and rework the problem. All right. Let's go into factoring, because we've been doing distributing monomials into polynomials for a while. So we kind of got the gist of that, watching our errors, making sure we're not making any mistakes. But factoring is another beast. It's kind of fun. We like factoring. Once you see the pattern, we're good. It takes practice. Slow your jets down, work through the steps, and eventually it'll become where you can use a lot of mental math. So factoring a polynomial just reverses the multiplication process. It's reversing our distribution. We're going backwards instead. Before we were distributing the term in, now we're trying to figure out what that term was that we distributed and pulling it back out. So when you are factoring a monomial from a polynomial, the first step, circle it, highlight it, what you need to do is to find the greatest common factor. Okay, so you guys have been doing this since, I don't know, 3rd grade, factoring out prime numbers. So we need to find the GCF, hiding in the polynomial. I'm going to show you several ways of doing this. You'll decide which way you prefer. So we're going to start the long way, which means we are going to list the prime factors. Okay? Then we're going to find the common prime factors and pull those out. So we start with each of the terms. I have 5x to the third. I also have 25x squared. And I have 45x. I'm factoring out primes, so I should start with the smallest prime other than 1. which is 2, and see if it divides in. If it doesn't, go to your next prime, on and on. So 2 obviously doesn't, 3 doesn't, but 5 does. And 5 is the only thing that factors in here. And then I know it's times how many x's. Since I add my exponents to get to my variable, then I know I must have added x times x times x. The factors of 25, 2 doesn't work, 3 doesn't work, 5 goes in there. 5 times 5, which are themselves primes. There are 2 of these x squared, so I must have had 2 x's because I added my exponents. All right, 45. Let's see. 2 doesn't go in there. 3 does. 3 times what? 15? That's 45. So 3, but 15 can be factored. So 15 is 3 times 5 itself. So 3 times 3 is 9, times 5 is 45, times x. I broke these into their prime factorizations. Now I need to go look and see what's common in all of them. I have only one x here, so I'm only going to circle one x in the other ones because that's the maximum amount of x's I have in this term, and they have to be the same in all of them. Then I look and see I have no 3's in either of these terms, so I'm not going to circle any of those. But I do have a 5 in all of them. I have a 5, and a 5. So my greatest common factor is equal to 5 and an x, 5 and an x, 5 times x. 5 times x. 5x. That will be what we do to pull out the term when we go to factor. So let's just practice finding the greatest common factors. What I'm really looking for is I'm looking at each of these terms and I'm figuring out the highest number that will divide into all of them. Well, if 3 is my lowest number, I need to start there because there's not going to be a bigger number that divides evenly into 3. So I look and see, does 3 go into 9? Does 3 go into 12? That's going to be the coefficient of my greatest common factor. But let's start with just practicing the process, and then we'll move into mental math and being able to factor without having to do these steps. So we know that 3 is just 3 times x 4 times, that's how I got 1 plus 1 plus 1 plus 1, which is x to the 4th. 9. 2 doesn't go in there, 3 does. 3 times 3 times x times x. 2 goes in there times 6, but 6 isn't a prime, so 6 is 2 times 3, so I can do that. And I have 1x that I'm going to multiply for. So I need to find, I have only 1x, so x is only circled once in each of them. I have a 2 here, but I don't have any 2's here. I have 1, 3, so I can only circle 1, 3 in those. So my GCF is 3 in an x, 3 times x, 3 times x, 3 times x. My GCF is equal to 3x. It's my greatest common factor that I can pull out of all of them. Okay, you're going to pause the video, then you're going to try the ones below, come back, check your answers, and we'll go from there. Okay, there are your answers. Check your answers. You should have gotten GCF of 3, 2W, and 2P. If you did not, pause the video, see if you can figure out where you went wrong. Make sure you are jotting down any questions that you have. Okay, so once you do find the GCF, or the greatest common factor of a polynomial, you can factor it out. They call it factoring it out. You can pull it out of the polynomial itself. So we're going to factor this polynomial. You also will see what is the factored form, right as the product of, or all kinds of language that deals with, hey, factor it out. What term did I distribute in to get this number? I want to pull that term back out. So first step is to find your greatest common factor, because that's what we want to pull out. We have 4x to the 5th, 24x to the 3rd, and 8x. Prime factorization of each of those, I get 2 times 2 times x times x times x times x times x. 1, 2, 3, 4, 5. 24. So it's 2 times 12, but 12 can be divided by 2. 2 times 6, but 6 can be divided by 2 times 3. Then we have x times x times x. If you are stuck on prime factorization, you need to come see me because you should already know how to do that. 2 goes in there times 4, but 4 itself can be chunked into 2 times 2, and we have 1x. We look for one variable, so there is an x in all of them, so we're good there. There is a 2 here, a 2 here, 2 here, sweet. I have a 2, a 2, and a 2, so I actually have another set of 2's in each of them. This is the only one with 3, so I can't pull that out, and these each have another 2, but this one does not, so I am done. 2 times 2 times x. 2 times 2 times x. 2 times 2 times x. So 2 times 2 is 4. Times x is 4x. That is the term that we are going to pull out into the front. Then what gets left is what we must have distributed into. 4x, this is what's left. X times x times x times x in this first term. So that must have been x to the 4th. What's left here, since it's minus 24 up here in the original problem, I got minus. I have already factored out my circles. I have 2 times 3, which is 6. X times x, which is x squared. Then it's a plus 8 in the original, so I know it's a plus here. I already used my circles. All I have left is 2. That is the factored form of this given polynomial. If I want to check it, I'm just going to redistribute it. So this is my answer. To check it, I redistribute it and see if I end up back where I was. So if I redistribute this, I end up with 4 times 1 is 4. X to the first times x to the 4th, I add my exponents. 4 times negative 6 is negative 24. X times x squared is x to the 3rd. 4 times 2 is 8. And x comes along for the ride. Is this the same exact thing where I started? Then I know what my answer is properly factored. All right, let's try a couple more of these. They're kind of fun. Once you get the pattern, we will start working with mental math, but I want you to start practicing this way with the whole greatest common factor method first. So let's start with these. We have a 9, a 27, and a 63. So 9a to the 5th is factored into its prime factorization, so 2 doesn't go in, but 3 times 3 does, and then I have 5 a's. I have 27a to the 4th. 2 doesn't go into 27, but 3 does. 3 times 9, but 3 can be factored, or 9 can be factored into 2 more 3's, and I have 4 a's. And then I have 63a squared. So what I would have done in my calculator was look for the smallest number that's showing up and see if it divides into each of these. Lucky for us, 9 does go into 63. I have 63 gets divided by 3. 3 times 21, but 21 can be factored into 3 times 7. Times a times a. If this seems crazy fast, that's because you don't have your GCF process down pat and you need to come see me. So we take a look. I have an A in all of them, so I'm going to circle that A. Ooh, look, I have another A in all of them, so I'm going to circle that A. I don't have a 7 in all of them, but I do have a 3. I have a 3 in all of them. Ooh, I have another 3 in all of them, so I'm going to circle those too. 3 times 3 is 9. A times A is A squared. 3, 3, AA, 3, 3, AA, so I'm good. So my GCF is equal to 3 times 3 is 9a squared. That is the factor I'm pulling out. So to finish, I have to go back and finish the problem. 9a squared times something got me back to the original polynomial. The something is right here. What I have left, a times a times a, is a to the 3rd. What do I have left here? I have plus a, I have another 3 up here, don't forget that 3. I have 3a squared, and all I have left down here is plus 7. That is my factored form. I can check it by redistributing it and seeing if I end up back here. Okay, for the next one I want to talk a little bit about using mental math and how I can do that without this huge long process, okay? I'm going to walk through it. If it turns out that you do not follow this and you need to go back to this, then go back to this, because this will always work. So I said earlier, okay, what is the biggest number that can go into every single coefficient? So I take a look at the smallest. I start with the smallest because that's the biggest number that can go in this one. 6 goes into 12, 6 goes into 24, but does 6 go into 15? Nope. So I'm going to look at the factors of 15. I know I have 3 times 5, so I'm going to make a little note up here. The factors of 24, 3 times 8. The factors of 6, 3 times 2. And the factors of 12, 3 times 4. So what's nice about this method is I can already see that 3 is going to come out in my factor. And then I look and see my smallest, just like my smallest number. I have to start there to see if it factors in. I look for my smallest variable. Because c to the first means when I factored it, it only had one c. So that's the only thing that's going to get circled. So it's the only one number of c's that can come out. So I know that my factor is going to be 3 and then c. 3c. Then I want to figure out what's left. Well, since I factored it, I know I have 5 left. And I divide each of these by what I already took out. C to the fourth divided by c to the 1. Remember, when we divide, we subtract. So 4 minus 1 is 3. So I get 5c to the 3. This term was a plus 24, so I have plus. Well, I have 8 left, so I'm going to have 8. 3 minus 1 is c squared. Minus, because it was minus up here, I have 2 left. 2 minus 1 is 2, so I have a c left. Up here I had used my 3, I have 4 left. Plus 4. And I divided by c, those cancel out, so I don't have any c's left, and I am done. If you are not ready for this method yet, you should go back to greatest prime factorization, circle the ones that are the same number in all of them, and pull them out like we were doing earlier. Alright, let's try one more where it's mental math and see if we can get it. Well, my coefficient on all of these is 1, so I'm going to pull out a 1, but that doesn't help me any. What's the maximum number of x's I can pull out? I can pull out x squared. What do I have left? Well, I divide everything by x squared since it's a variable and figure out what I have left. X6 divided by 2, I subtract, so I have x to the 4th. Minus 4 minus 2, which is x squared. And x squared divided by x squared, anything divided by itself is just 1. And you have your factored polynomial. Okay, again, don't freak out. I want you to try the next ones, work your way through them, pause the video, and then come back. Practice doing both ways. See if you can get the mental math. If not, use the greatest common factor process every single time. So pause the video, come back, check your answers in a sec. Okay, I used a combination of greatest common factor methods and mental math on this, the cheat sheet way. So check your answers. Your final answers are the factored forms. If you did not get them right, you need to go back, retry them, and if you're still struggling, then circle them so we can talk about them in class. So this is the answer for the first one. This is the answer for this one. This is the answer for this one, which clearly I have not finished, so let's do it real quick. We pulled out 3x. What do I have left? I have a 3 times 1, 2, 3, 4. 3x to the 4th. This one I have a 5, and I have x squared, so plus 5x squared. And this one I have 2 times 2, which is 4, plus 4. There's that final answer right there. And then there's your final answer there. Again, I can always go back and check these by redistributing them in so that you can get back to the original problem. Alrighty, I'll see you guys tomorrow with your questions.